Okay, let's see what this madness is. The big thing is to figure out these parentheses. So it's 15 theta all times all of this. And that's important because this is actually a product rule where the 15 theta would be your f of x and all of this is actually your g of x. Okay, so doing our product rule, we know we're going to take the derivative of the first one, leave the second one alone, plus take the derivative of the second one, leave the first one alone. So this one gets kind of crazy because of this right-hand g of x size is just quite large. If I start this, the derivative of 15 theta is just 15. And then I leave all of this alone. So let's kind of see if we can see what's going on here with our parentheses. So all of this is inside the sign, close the sign, plus the cosine of ln, got my colors off, of ln of 15 theta. We close the cosine, and now we close this parentheses. So the problem is that's just the first part of the product rule. That's just this piece right here. I still got to do the other piece, and in fact that was the easy side. So from here now, let me see if I can keep writing this so it doesn't get too little. This is where we say leave 15 theta alone and now take the derivative of this whole g of x business. Well, this is a good time to really say if you will use the shortcuts, then I'm looking at the derivative of sine of ln of 15 theta. Well, the derivative of the sine is the cosine, and I leave everything inside alone, times the derivative of ln, which is going to be, this is probably going to get so small, but we'll see what happens, which is going to be 1 over 15 theta, and then times the derivative of 15 theta, which is 15. Well, once again, that's just the derivative of that piece, so I've got to do the cosine piece. So trying really hard to squeeze this in, not sure I'm going to get it. The derivative of the cosine, well, let's go ahead and do this right now, is minus sine. So I'm going to have minus sine, and let's just move this and we'll move it around. And I leave the inside alone, which is ln of 15 theta. I take the derivative of ln of 15 theta, which is 1 over 15 theta, and then times the derivative of 15 theta, which is 15. I think you need a longer piece of paper for this, right? And now I close this parentheses. So this is saying 15 theta times this piece, if I distribute it, and then also times this piece. Why that's important? Since both of them have a 1 over 15 theta, those cancel. Okay, so it's important that you know that. If it doesn't make perfect sense to you, you could actually just factor out a 1 over 15 theta out of both pieces, and then you would see it would cancel. So let's move back over here and see if we can rewrite this. So I'm going to have 15, all of this just stayed the same, ln of 15 theta, close, close, plus cosine of ln of 15 theta, close, close, close. Now over here, all I have left is this madness. So that madness being just write it in blue so we keep the same colors, is so I still have this plus sign. So plus cosine, well, in fact, let's throw the 15 out front. So see that 15 right there? 15 cosine of ln of 15 theta. And then this piece right here, I still have a 15, so a minus 15 sine ln of 15 theta. And even though this is big and ugly and huge, is if I distribute this, I'm going to first get 15 sine ln 15 theta plus 15 cosine ln 15 theta. So that's all of this distributing the 15. Well, let's take this other business over here and let's just write it under the same terms. So 15 cosine ln of 15 theta. So that's that piece. And then over here I have a minus 15. So I'm looking right here. Minus 15 sine ln of theta. Well, guess what? That's just the opposite of this piece. And so that's going to cancel. And thus my answer is found by adding these to get 30 cosine ln of 15 theta. So what a doozy, right? But certainly it's just a very long problem and then a lot of chain rules.